So let's go back to this first chapter, first section. Yes, today is about the material and tissue of the living body, and also the feature of body tissue, and the living creature structure and the functional features. I will talk about that. Yes. Firstly, the material itself. And what is a living thing? What is a living creature? It is separated from outer world, external world by some membrane, in terms of membrane. And the cell is the smallest unit of the living creature. Okay? Cell ね。セルはなんかウォールがあって、これはメンブレーンですね。And yes, this is separated from outer world. And next is yes, and material and information can be exchanged. Some material and information can be exchanged inside and outside cell, or outside living creatures, or sometimes it is gathered and make some organization and something, and living individuals maybe. So the information and the material can be exchanged from between the inside and the outside of the cell or living creatures. But it is practically some material is exchanged. So the material exchanged becomes information exchange. Okay. And also reproduction ability is there. So the cell itself or some similar structure can be reproduced. So therefore, the living life form is make some evolution, because it is infinitive number of birth and death is reproduced. So therefore, it becomes adaptable to the environment, evolved to be adaptable to environment. So this is a very, very long term birth and death repeatedly. So this living thing become so environmental adaptation is very, very high. So here. And the environment and the information exchange is the physical measures, physical way. So I have said. So information is exchanged outside and inside, but the information itself, not the information itself, but some, for example, the chemical material is exchanged. So the information can be received in the living thing. The cell and the information exchange is through the cell membranes. Some protein transferred becomes the information exchange. Some protein is moved, transformed from inside to the outside or outside to inside. And also metabolism. Metabolism is some synthesis of some material and decompose of material, and so their material transformation makes energy to make live this cell or some organization or cell. So some material is transformed. By transformation, the energy is produced or consumed. So by using this, the cell is living for some period. Interaction with environment. So the one important point on the Earth is gravity. Gravity is applied usually. Gravity is applied usually. So some stress, some physical stress is applied to all the living creatures. So it is one important aspect for the living creatures on the Earth. Yes. Next thing. Next is material and tissue. Material. So what is the material of the living creature? Is organic material, mineral material, and water. Organic material is like the protein. Mineral material like the hydroxyapatite. What is organic material? What is mineral material? Your idea, what is your idea about what is organic?
I think cereal.
Cereal?
Can breathe the oxygen.
Oxygen? What is mineral? No life? Yes, maybe that. Yes, you should find some definition later, maybe. It is one of your homework, maybe. Okay? And you know how much amount of water is inside of the human body? Do you have some idea about which amount of ratio is there in the human body? Person's weight. 90%?
More than 70%.
Yes, you should search later after the class, okay? You should do. Yes, maybe the 80% or something, maybe. And you should find the correct answer on some pair, maybe after the class. So, and issues, hard issue and soft issue. For example, the hard issue is a bone or teeth, is a hard tissue. And the soft tissue is some skin or muscle or some vessel wall or something. Yes, it looks like this. Okay. So the next I will introduce example of the hard tissue and soft tissue. So one of the hard tissue is maybe the bone. Bone looks like this. Maybe you know about the bone. And the bone has some the compact bone and the sponge bone. So the compact bone looks like this kind of surface area, and it has some layers. So face of occupied hard path. Ostain is a bone unit. Ostain is here. This is ostain. The center of it is some pipe, Haber's pipe, Haber's canal. Haber's canal is here. Some collagen fiber, and also some apatite is here. So this kind of mineral is put on this ostain. So the ratio of this collagen and apatite makes the feature of this bone. Yes, I will show some video on here.
Spongy bone contains a mesh-like network of trabeculae, while bone marrow fills in the empty spaces. Bone's external layers are compact bone, while the internal layers are spongy bone. Densely packed cylindrical structural units called osteons or Haversian systems constitute compact bone, and in a long bone lay parallel to the long axis. A central canal or Haversian canal lies in each osteon and contains perforating canals or Volkmann's canals that branch out at right angles. Haversian canals contain blood vessel nerves, and small branches stem off into the perforating canals to connect to the periosteum's blood and nerve supply. The bony tissue's osteon surrounds a series of concentric lamellae, or layers, where lacunae, or osteocytes, fill in small gaps. Canaliculi, or small tunnels, connect lacunae to each other, and the lacunae's inner ring to the central canal. Cellular processes in the canaliculi allow osteocytes to communicate with each other. Except the epiphyses, where cartilage is attached, the periosteum covers the bone's external surface. Its external layer consists of dense irregular connective tissue that facilitate bone and muscle attachment, while the osteogenic or inner layer contains bone-creating osteoblasts and bone-destroying osteoclasts.
例えばこういうのがありますね。はい。Yes. For example, this is an example of the hard tissue, compact substance, compact bone. And yes, collagen. Collagen is some of the cosmetic material is used. What is the effect of the collagen? You know, Martha, what is the effect of the collagen for the cosmetic issue? Yes, you should find later after the class meeting. Okay? Yes, the next is an example of the soft tissue. Soft tissue's example of the soft tissue is a blood vessel. Blood vessel. Here, blood vessel is 3 layers, has 3 layers. This is intima, media, and adventitia. Yes, here. So the intima is one layer or vascular endothelial cell. Yes, only one layer cells. And media contains muscle cells. Muscle cells, どっかで書いてある? Yes, maybe, yes. Smooth muscle cell. Smooth muscle cell and elastin and collagen. These 3 material is a component of this media. The elastin is elastic, so deformable, easy deformable, and collagen is hard to be deformed, and the smooth muscle is a muscle, so that by some stimulus or material it is contract and relax. Okay, so these 3 components, the ratio of these 3 components will be changed, mainly depending on the length from the heart, distance from the heart. Why it is? Distance from the heart. Yes, distance from the heart means, yes, heart is here, maybe, heart is here, and the, yes, blood vessel, the main blood vessel is from here to the lower body, maybe. So this is a vascular vein, and yes, these 3 materials, the ratio will be changed depending on the distance from the heart. What it means? Yes, media contains this smooth muscle, elastin and smooth muscle. So it can be the diameter of the vein will be changed easily changed sometimes. Okay, so the heart beating makes pumping. Pumping has some yes. なんていうかな、ドックンですよね。ドックン。So the blood pressure will be changed, maybe. So yes, if it is constant, the diameter is constant, this pressure, blood pressure changing is affected to the blood vessel, and also it not smoothly flow, maybe. Yes, this part is smooth to make the large amount of pressure will be there, but in this case it will make some low pressure, so the flow is not so smooth. So make it flow smoothly, the diameter will be changed depending on its pressure. So that near this part, this elastin, the ratio of elastin become higher near to this heart. So and after this, this diameter should be constant. So the Kragen's ratio become high. The longer distance. So the position, depending on its position, the content rate or orientation is very, very greatly varied. For example, thoracic aorta, elastin is higher, become blood vessel, become deformed, and blood should be transported efficiently. And diatydomic, this kind of legs artery, the collagen become higher, so it can be deformed when it is moved. Okay, should be keep its diameter, so the collagen's ratio become higher. Okay. So for example, you should watch this video and.
We previously learned that blood is carried to your cells through tissue advent the tunica blood vessel to withstand some stability.
Yes, so only some summary will be provided.
All arteries and veins contain 3 layers. The innermost layer is called the tunica intima. The muscular middle layer is called the tunica media. And the outermost layer is called the tunica adventitia. Because capillaries are only 1 cell layer thick, they only have a tunica intima. This ultra-thin design allows for the exchange of gases and nutrients through the capillary walls. The smooth muscle found in the tunica media can be stimulated to contract, and this results in vasoconstriction and the narrowing of the blood vessel. When the stimulation stops, the smooth muscle relaxes, resulting in vasodilation and the widening of the blood vessel. The ability to contract and dilate helps to control the amount of blood flowing through the vessel.
Yes. If you watch more, you can access this video later. Yes, the next step is a feature of living tissue. Living tissue is so the composite material. Multiple material is composed. Next is a inhomogeneous structure, not even, inhomogeneous, and anisotropy. Anisotropy is the different direction it's facing. Depending on its function, each material is oriented in various directions. So it makes some various features. Yes, maybe you can understand. If something is aligned in the same direction, it is this material has some the even, uniform feature maybe, but sometimes it has some different direction. Yes. This thing has some various directions, so that it can, yes, for example, it can be deformed. For example, this direction, it is hard to deform this direction, for example, but in this condition, maybe any direction is the same feature, maybe. Okay, so the alignment makes the different feature even if the same material. Okay, and deformation, large deformation. Most of the living tissue makes a soft material, consists of most soft material, so that it can be deformed easily. So the skin can be changed easily, so much. Yes, maybe the cheek, for example. Yes, and also viscous elasticity, and non-linear. What is viscosity? What is elasticity? You know what is elasticity? What is viscosity? 成田 What's viscosity と elasticity と何ですか What is it?
なんですかね伸縮性みたいな
ビスコースって粘性 What is viscosity? Mainly it is なんか B とかだよね弾性エラスティックってなんか K ですよね maybe ねそれ俺さなんだっけフィジカルマテリアルさ例えばどういう形なんだっけこうで例えばこうでダンパースプリングダンパーでねスプリングダンパーマスでね例えば K、B、M マススプリングダンパーでねマススプリングダンパー系は何ですかって言ったらなんかこう F がアプライしたらなんかこう X が変形しますよね F イコール mx2 ドットと b の kx ドットと kx だよね x だよねでこれがまあなんだっけアクセラレーションでこれがなんだっけビスコーシティでこれがエラスティシティでねパートでこれは F は何ですかって言ったら M のこれの V と違ったごめん V のドットと B の速度と K のこれだよねこれなんでこう書きますかって言ったら Yes this is here is a physical work from electric circuit でエレクトリックサーキットは何だっけ LRC ってあるよねこれはなんかメカニカルの方ではMBK 系ってあるけどそれに対してエレクトリックフィールドでは LRC ってありますよねこれなんかソースがあってなんだっけ L はコイルかでレジスターとコンデンサーのキャパシタンスがこうやってでねこれは何ですかって言ったらこれがこれはこうやってこれ V だよねでこれ流れるのが I だよねだから V は V イコールこれ何 LRC だったらどうするのIR と I の C は何だっけコンデンサーが これのインテグレーションですか？これは何ですか？ L で I のこれか、こうですか？だから I、V っていうのがこのエレクトリカルフィールドの話で、こっちは速度ベロシティと F がベロシティと F のバリアブルとこの V と V っていうかまあ E だよね。E と I のバリアブルだよね。が Yes, this is the relationship, the same form, but this is a parallel element, but this is serial element in the circuit. Okay? You remember of this physical world and electrical world. Yes. So the viscosity, elasticity is a damping factor and spring factor. Okay? Damping factor and spring factor. And non-linearity. What is non-linearity? 黒いシャツの、ブラックシャツの人。What is non-linearity? What is non-linear? じゃあ What is linear? What is linear? Some idea? What is linear?
Y is equal QS.
ああ、KS？ KS、ちょっと待ってよ。なんだっけ。インプットとなんかアウトプットだよね。アウトプットだよね。で、リニアは単にリニアだよね。リニアリレーション。インプット、アウトプット、リニア。で、ノンリニアはany line non-linear. Any line non-linear. Linear is only line. Yes. And also incompressible because of water. So I asked the previous slide. The living creature contains a large amount of water. So water cannot so compressed change its volume. So it is not easy to compress. So it is compressible. So these things, these features, based on these features, it is not easy to assume like other industrial materials. So some assumption cannot be applicable to the living organizations. What it means? What it means? What is the key point? Yes, large deformation, not incompressed, and some viscosity, elasticity, and non-linearity, and the uneven organization, anisotropy, for example. Yes, this kind of feature makes fat 成田。こういうのがあるとどんなことになりますか？ Fat makes this。
センサーとかで得られる値と人間が感じる値が大きく異なるっていうのが一つ特徴かな。
よくわかんないけど、はい。センサーとthe feeling and the sensing value is different.
It is, はい。
とあとはなんか
人の生体組織はかなり複雑な行動をしているので工学的なモデル化ができない。
ああ、そうコンプレックスでね、very very complexity. So complexity. So the yes, engineering. If we want to treat something in engineering aspect, engineering point of view, we want to make some model だよね。モデル。ね、モデル。Yes, for example, yes, さっきの KBM のなんかモデルとか LCR モデルとかリニアモデル sometimes non-linear model. By using some equation, by using some model, we can calculate something, input-output relationship, estimation about the input-output relationship or something. But yes, this kind of uneven structure, anisotropical structure, so it's not easy to model it's not easy to construct, develop some model of living organizations. So it's hard to treat engineering viewpoint. So yes, it's very special. It requires some special thinking, some special methodology to treat the living things, living creatures, living organizations. Okay? はい。あとは、next feature is optimal design. So as I said, the many generations evolution. So we think we can in one aspect. So we estimate if the living thing is optically designed in present form. So for example, this is bone. Bone ですね。じゃあさ、same intersection. This is a cylinder, and yes, this is pipe. The same area. Or もっと薄いやつか。Pitch is hard. For example, これなんだ。例えばこっちの F. The same F is applied. これ全然わかんないですね。これやめよう。こうじゃなくってやっぱり横からの Yes. Same F is applied, same force is applied, which can be deformable, which is hard. ないな、これどれが一番いい？
いいと言いますとどういう意味？
いや、いろんな意味で。バリアスに。
曲がりにくいとか曲がりやすさとか評価によって違うんですけど、
曲がりにくいのは？
曲がりにくいで言いますと一番右側になると思う。素材にも
こっちは。これ素材による。これを部分的に変形したら困るよね。
はい、
だけど、yes, this is maybe the hard to deform, maybe. This is, yes, this can be easy to 曲がりやすいね、こうやってね。Easy to bend, maybe. It is hard to bend. Hard to bend, maybe. If the same weight material, using the same weight material, this cylinder is これもだから厚さ程度によるよね。But large diameter makes makes is hard to bend, maybe. So this is also the long bone. Long bone has some, yes, both end of the long bone has a large diameter, and it contains the inside is sponge bone is inside. Sponge bone makes some dampering factor or cushioning factor effect maybe, and this portion is thin but the vacant, yes. So it makes the lightweight and the structural strength. Both two features makes the maximum. So that this kind of this part is makes the shock absorbing, and this part is makes the some lightweight. Yes, looks like this. For example, so firstly the bone is maybe the same diameter, same thing, but after some generations, it makes become thin and become larger, maybe. So it is thin, it is optimal designed in present form. Okay, this is one example. But in other case, sometimes it is homeostasis. Homeostasis making if changes the outside of body, some atmosphere will be changed, but the inside is keep in constant, maintain its constant. For example, yes, we are human being. Human being's body temperature is about body temperature. Human being body temperature, how much?
37.
37 Celsius. Okay? Yes. Oh, yes. When he is go to under the sunline, yes, or both north and both south end, yes, he can keep his temperature. If it changes atmosphere, yes, very high temperature, go to the desert, go to the icy condition. So body temperature will be kept about around 37 degrees. So it is the homeostasis. Okay? But sometimes remodeling is also happened. Remodeling makes so it is human body in some cases adapted to the atmosphere or conditions. For example, the astronauts, maybe some astronauts go to space, the low gravity. So while he is going to the low gravity condition, the muscles power will be reduced. Muscle condition will be reduced. So sometimes after coming back on Earth, astronauts cannot stand by himself because during staying in space, low gravity condition, the muscle ability reduced. Okay? So sometimes it's adapt to, it is called remodeling. Okay? So it is, and kinetic functional adaptation is also there, residual stress. So for example, this is a cross section of the blood vessel. Blood vessel has some blood pressure inside. So the blood pressure is inside here. While in the blood vessel, blood pressure condition, each of the cross section of blood vessel becomes the same stress condition it will be by using the inside residual stress. The stress is applied usually while some blood pressure is applied inside the vessel. So when no blood is here and cut on here, by using this residual stress, it can be opened. Just it shows some kind of stress pre-force is applied to this limb. Okay? ちょっと時間がないので Yes. The next 3 slides shows some structural and functional features. First feature is skeletal structure. Skeletal structure is bone, joint, and bone. In human being, about 200 pieces of bone and about more than 600 kinds of muscle is there in the body. Yes, and then next is a joint structure. Bone joint structure is here, is there. Yes, bone, the link joint structure is inside of the body. For link joint structure, and the joint, hip joint, knee joint. For example, hip joint. What is hip joint? ヒップジョイントはどうですかって言ったらなんだっけ、こうなってこうなって、まあこうなってこうこう。ヒップジョイント、ここですね、ここ。ヒップジョイント。で、yes, bone is here, like this. And knee, yes, hip joint is this ball is inserted, this cup. Hip joint here. So the hip joint is a cup ball condition. So the cup ball condition makes the three-dimensional 3 degree of freedom joint. 3 degree of freedom joint it means that it can move this right and left, go forward and back, and rotate. So 3-dimensional joint is a hip joint, for example. The shoulder joint is also the same. 3-dimensional joint, right and left, and forward, back, and rotate. So 3-dimensional joint is the hip joint or the shoulder joint. Spherical joint looks like this, ball cup condition. Okay, but the knee joint or elbow joint is 1 degree of freedom. The simply modeled in 1 degree of freedom, only bending and release. Okay, so 1 degree of freedom joint, and it contains some water to make smooth and reduce the friction coefficient. So joint fluid makes the movement smoothly. Yes. Yes, this video is interesting, so I hope you will watch later. Okay. And then, so final slide is here. So the muscle structure. Muscle. Most important thing is agonist-antagonist muscle action. Because you should remember that the muscle can only マッスルか。マッスルね。マッスル can only contract and relax. Contract, relax. No expand, only contract. So the both side muscle is necessary to make, for example, to make this link move to make あれこれじゃねえや。そうここにジョイントがあってここにリンクがあったらジョイントリンクストラクチャーでここがマッスルで to bend left, yes, this muscle contract, to bend right, this muscle contract, release contract. So this kind of pair is called antagonist muscle action. Agonist, antagonist. Okay, so you have to remember this kind of, yes, only contract and relax, but extend, but cannot extend. So that to make the both side movement, this pair is necessary. And sometimes both contract. What it make? Martha, when both sides contract, what it make? Contraction. Simultaneously, both muscle is contracted, so it makes the contact pressure distribution is even, makes it even. So this contact point makes even. Not only the partially contact, but to make it the even contact by using some soft tissues, and also yes, joint motion skillfulness, dynamic stability improved. Yes, this joint is modeled like this. Link joint structure. Link joint. Yes, I will use other. Yes, this link is here, and also the yes, called right left bending. So the theta to だから yes. So therefore some torque is applied. Torque to theta relationship maybe. So the spring constant K is there. So this K can be changed by adjusting this simultaneous contraction. When this antagonist released, easy to bend. So the K is T イコール K シータだとしたら easy to bend は K が小さいニュートンメーターパーラドだから小さい Yes, K is easy to bend, so K become smaller, but to the yes, both side pulled, the K become larger, not easy to bend, so hard to bend. For example, yes, maybe you can adjust this spring constant. Yes, sometimes it's easy to bend, but sometimes it's easy to hard to bend. For example, if your hand is fixed to something, yes, I have applied some forces, but not easy to move, so become hard this joint. But sometimes, yes, relaxed, easy to change, to deform. So this joint K, spring constants, can be changed by exciting this muscle or relaxing this muscle. Okay, so both contraction can change its spring constant. Okay, この easy to deform or hard to deform. Okay, so it makes some sometimes the precise positioning is necessary. So sometimes it makes this elbow angle. It's hard to deform, but adapt to something. You have to make the freely or relaxed of this joint. So it's in this case you make the muscles relax. So contraction is make some different so adjustable feature of this joint feature. Okay. Yes. You are interested in? Maybe you should watch the video later. Okay. Yes, that's all for this week's talk. Yes. Yes, this kind of antagonist muscle structure is used also on the robotic joint. If you are interested in, you should examine about search on this kind of robotic joint.